In these problems, we need to solve a system of three equations with three variables. And there's a lot of work involved in this. So let me tell you the process. Basically, what you do is you pick two out of the three equations, and maybe through the process of the method of elimination, you get rid of, let's say we'll get rid of the z variables. Actually, as I'm looking at this bottom equation and the top equation, you have a negative 3z and a positive 3z. So it might make sense to try to get rid of the z's there. Then we'd take two other equations, maybe this middle one and either the top or the bottom, and try to get rid of the z's there. And at that point, we'd be down to two equations in two variables, and we'd repeat the process to try to eliminate another variable until we can finally solve for one. Once we've got one variable, we'll plug them back in and work our way back out to the other answers. So let me show you how that works. I think I'll start with these two equations right here. So 2x plus 4y minus 3z equals 24, and x minus 5y plus 3z equals negative 39. So we're going to go ahead and add those together. I don't have to multiply anything because my z's are going to disappear here. And I get 3x minus y, z's disappear, equals, and I think that's a negative 15. Now I'm going to have to choose this middle guy here, and I think I'll take the top one. And I'm still trying to get rid of the z's, and I think what I'm going to do is multiply the top equation by 4 and multiply the middle equation by 3, and then we'll have 12, positive and negative 12z on each of them. If I do that, I should get 8x plus 16y minus 12z equals 96. Yeah, I think so. And then 18x minus 3y plus 12z equals, oh, and that's negative 96. Huh, interesting how that worked out. So let's add these together, and we get 26x plus 13y. The z's disappear, and this comes out to 0. Now what we have is two equations in two variables, and we will work with these to solve, again, to try to solve for one of those variables. So we'll line those up, and we got 3x minus y equals negative 15. And we're going to need to multiply by something here. Let's see, I think I'll multiply this one by 13, the bottom one. So that would be 13 times 3 would be 39x, and this would be minus 13y. And let's see, negative 15 times 39 is going to be negative 195. So now we can add these together. Boy, some big numbers we're getting. This would be 65x. Whoops. And the y's disappear, a positive 13y and a negative 13y, and that's a negative 195. Aha! Now we finally got it down to the point where we can divide both sides by 65 here and actually solve for one of our variables. Once we've cracked one of them, it gets a lot easier. And let's see, this comes out to x equals negative 3. Now what we want to do is take that value x and plug it back into one of our previous equations. I think I'll use this one. Oops. This one up here, it looks pretty simple. So 3 times x, which is negative 3, minus y equals negative 15. So that's negative 9 minus y equals negative 15. Add 9 to both sides. You get negative y equals negative 6, or y equals 6. Now we've got two variables, and we can use both of those and plug those into one of our original equations and find our final variable here. So x is negative 3. I'm going to use this top equation up here. So 2 times a negative 3 plus 4, and y was 6, times 6, minus 3z equals 24. So we've got negative 6 plus 10 minus 3z equals 24. And so that's 4. We subtract 4 from each side. All right, what did I do wrong there? Haha, 4 times 6 is not 10. There we go. So that's 24. So 24 and a negative 6 is 18. We subtract 18 from both sides. We get negative 3z equals 6. and divide by -3, z equals -2. So there we go. We've got our z, we've got our y, and we've got our x. So we have completely solved that system of equations. Let's try one more. This one might be a little bit easier, because as I'm looking ahead here, this top equation and the bottom equation, it looks like we're going to have a couple of things disappear. I would probably line these two up first to do elimination, and I would multiply one of them by a -1 to change all their signs. So let's leave the top equation the way it is, x minus 2y plus z equals -10. This bottom one, I'm going to multiply everything by -1, basically just flipping the signs. So -x plus 2y plus z equals +8. Now when I add these two together, two sets of variables disappear, which is a nice shortcut. So that's x's are 0, y's are 0. I just get 2z equals -2. So z equals -1. I've already got one of the variables. Now what I can do is choose two other equations to try to simplify, and then when I line them up for elimination, I'll plug in -1 for z. Let's look at these two. Looks like they're set up already to get rid of the y's. So x minus 2y plus z, well actually that's going to be plus a -1. So we'll put that in there, equals -10. And 3x plus 2y plus 2z, which is 2 times -1, equals -13. Now let's go ahead and add these. We get 4x, the y's disappear, we get a -1 and a -2, so that's a -3, and here we get -23. We'll add 3 to both sides. We get 4x equals -20, or x equals -5, dividing by 4. So now we've found two variables. We have our x, we got it lucky and found our z right away. So we can choose one of these equations at the top, plug in our values, and solve for y. So x is -5. Let's just do this top one. -5 minus 2y plus z, which is a -1, so -1 equals -10. So that's a -6. We'll add 6 to both sides. We would get -2y equals -4. Whoops. And divide by -2. And we get y equals 2. And there we go. We found x, y, and z. So we have solved this system of equations. So that's a little bit of work in solving systems of 3 equations with 3 variables.